All right, welcome back. We're on number 5. It says simplify and state restrictions. Okay, so when we simplify rational functions, it depends if we're adding and subtracting. To add and subtract fractions, you need to find the greatest common denominator, or the least common denominator, the least common denominator. So to find the LCD, we need to look at our function and factor the denominator. So remember, I started off by saying simplifying, it depends, add or subtract, we're going to need to find the LCD. If we were multiplying or dividing, we would not need to get an LCD, but we are adding or subtracting. So to find the LCD, we're going to factor the denominators. That gives me x plus 2, x minus 2. This one does not factor, it's already linear. And then multiply by missing factors. And then remember, if a factor repeats, then you don't multiply by that again. All right, so this one, the LCD in this case is going to be x plus 2, x minus 2. So this factor, or this term is missing the x minus 2. So I will multiply both the top and bottom by x minus 2. All right. So this is 6x minus 2 over the LCD plus, multiply through, we get 2x squared minus 4x plus x minus 2 over the LCD. All right, I'm going to combine like terms in the numerators. So I have 2x squared, nothing combines with that. I have a 6x, a minus 4x, that gives me 2x, and then a plus 1x, that gives me 3x. And then negative 2 and negative 2 is negative 4 over my LCD. Now at this point, so after we find the LCD, right, then we simplify the numerators. And at this point we have to check to see if there's any kind of reducing that we can do. So to check for reducing, we're going to have to see if the numerator factors. So remember, this is a leading coefficient of a 2. So if it does factor, we'll have to use factoring by grouping. So we would need something that multiplies to a times c. Normally a is 1, so it's just c. But we have to multiply to negative 8 and add to 3. And so we have to decide if there's anything that does that. There's nothing that multiplies to negative 8 and adds to 3. So this is done. 2x squared plus 3x minus 4 over our LCD of x plus 2, x minus 2. It does say to state restrictions. Our restrictions are x cannot equal negative 2, x cannot equal positive 2. Number 6, given the function y equals x squared minus 4 over 2x squared plus 11x plus 14. A, determine the horizontal asymptote of the graph. Okay, so to determine the horizontal asymptote, there are 3 rules. And you have to decide which one you have. So either the degree of the numerator is smaller than the degree of the denominator, or the degree of the numerator is greater than the degree of the denominator, or the degree of the numerator is equal to the degree of the denominator. So you have to decide which of these 3 we have. So looking at this equation, I see that the degree of the numerator is squared and the degree of the denominator is squared. So they're equal. All right, but I'm going to state the rules for each one. So this is the one we have. In this case, it's the line y equals c, where c is our constant. So for example, in this one, if the degrees were different, like we had x minus 4 over 2x squared plus blah, 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 right, plus 2, right? Our constant term is actually not 2. Our constant term is right there, 0. So generally, it's y equals 0. On IXL, sometimes we saw a constant term here, but in the book, we rarely see that. I think it was like on one exercise. Okay, if it's this case, the numerator's got a larger degree, then there's no horizontal asymptote. And then finally, if it's our case, then it's the line y equals a over b. And so a and b come from the leading coefficient of the numerator and the leading coefficient of the denominator. So the leading coefficient in the numerator, right here, there's a, it's 1. And the leading coefficient in the denominator, that's b, it's 2. So 1/2, or it says in decimal form, which is 0.5. Okay, next, this is part A, right? Find the horizontal asymptote, which is the horizontal asymptote is at 0.5. Part B says, determine the coordinates of the point of discontinuity that is a hole. Oh, write your answer in coordinate format. Okay, so to find a hole will make both the numerator and denominator 0. So to find a hole, we're going to have to factor the numerator and factor the denominator. All right, so when we factor the numerator, it's a difference of squares, which is x plus 2, x minus 2. When we factor the denominator, I want you to notice we have a leading coefficient. So we need to find, we're going to have to factor by grouping. So we need something that will multiply to a times c, which is 28, and it adds to 11. And those two numbers are 7 and 4. Again, we cannot just say x plus 7, x plus 4, because we have a leading coefficient. If we had x plus 7 and x plus 4, this will not multiply to 2x squared. It's just x squared. So it's not this. All right, so factor by grouping, just to refresh your memory, you take this middle term and you split it into these two terms. So this is going to be 2x squared plus 7x plus 4x plus 14. And then we'll split it and take out the GCF of each side. So the GCF here is x. That gives me 2x plus 7. Bring down that sign. The GCF here is 2. That gives me 2x plus 7. And then I split it again. The GCF is 2x plus 7. And then x plus 2. Again, we're looking for a whole. I'm going to rewrite this. It's x plus 2, x minus 2, over 2x plus 7, x plus 2. A whole will make both the numerator and denominator 0. So what I see is that there's a common factor, which is at x plus 2, right? So x plus 2 equals 0 means x cannot equal negative 2, right? Negative 2 is our hole in the graph. We have a vertical asymptote. This is our VA, our vertical asymptote. This is our hole, also called an extraneous solution. And then our solution is 2. comma 0, right? So our coordinate form, so I know I just told you in class x equals -2, but in coordinate form, our whole is at -2, comma, undefined. Okay. All right, that was number 6. So let's go ahead and look at number 7. So flipping it over to the next page. Okay, the function below has a parent of 2 over x. Now that's good because that means that we don't need to worry about any scaling, right? They're all 2 in the numerator. Which of the following functions represents the graph based upon asymptotes? So we just need to know what our asymptotes are. So our horizontal can be found at y equals k, and our vertical is at x equals h. All right, so looking at the graph, it appears that there's a vertical asymptote right here at -1. So our vertical asymptote is at x equals -1. And then our horizontal asymptote is right here. It appears to be at 3. So I can get rid of this one because it's -3. And I can get rid of this one because there's no shift in x. I just have to decide if it's at -1 or +1. Remember, when we put a negative under the radical, or sorry, not under the radical, when we put a negative into our function, y equals a, and then times x over, or sorry, no, times 1 over x minus h plus k, right? Minus h, it'll always become positive. So negative times a negative will be a positive, so it will be +1 at C. All right, I'm going to cut the video here. I'll pick it up on the next video.